morning, students. Now next theory is G. Acceleration due to gravity above the surface of Earth. What is the meaning of this? See, here it is. If it is Earth, okay. If it is Earth, it is its center. Okay. Now, above the surface of Earth means not only this point. Okay. These all points are considered as above the surface of Earth. Clear about this? Okay. So, acceleration due to gravity above the surface of Earth. Above the surface of Earth means this all points. All point outside Earth is called acceleration due to gravity. Acceleration due to gravity above the surface of Earth. So I am taking one point here. I am taking one point here. Okay. Okay. So at this point, what is acceleration due to gravity of Earth that we have to find? See, I am assuming with this total distance. We know that from the center of Earth, it is R. Yes or no? Yes, it is. This distance, it is called R, radius of Earth. And see, now this distance, it is H. H means height above surface of Earth. H means height above surface of Earth. Clear about this? Here, one object having mass m is placed. So, what is situation? See, as shown in figure, object of mass m is placed at height h above surface of Earth. Above surface of Earth. As shown in figure, object of mass m is placed at height h above surface of Earth. Clear about this? Okay. Now see, R is distance from center. So therefore, distance from center R is equal to, from figure it is very clear, R is equal to, it is R plus H. Yes, it is R plus H. Simple. So distance from center R is equal to, it is R plus H. Any doubt? Any doubt? Okay, so yes, here distance from center R is equal to, it is R plus H. Now at this point, that is outside Earth, at distance R, what is gravitational acceleration? We have obtained formula. Okay, so now outside Earth, that is for R greater than RE, gravitational acceleration we know its formula. Okay, what is gravitational acceleration? Or if we want to find step by step, then outside Earth, gravitational force that is F is equal to, it is simple, G m upon R square. See, R square. Why to consider whole mass of Earth? Because point is outside. So these all spherical shells, their masses will be concentrated at its center. Okay. So this F is equal to G m upon R square. I can also write this as is equal to, it is G m upon. I can replace this R by RE plus H whole square. Clear? So therefore, gravitational acceleration at height h above surface, GH is equal to what is gravitational acceleration? It is F upon m. So if you perform F upon m, it will be G me upon r square, or you can write it is equal to G me upon re plus h whole square. Any doubt? So see, m you have to take this side, so F upon m, G me upon r square, G me upon re plus h whole square. Any doubt? Okay. So yes, it is equation number 1. Now we know that gravitational acceleration on surface of Earth, that is G. Wait a minute, okay, that is GE is equal to G me upon re square. Yes, we know it. Yes, we know this. Okay, the gravitational acceleration on surface of Earth, GE is equal to G me upon re square. G me upon re square. Now I will take ratio. Equation 1 divided by 2. So yes, it is GH upon GE is equal to GH means this equation. G me upon re plus h whole square, and GE, there are two methods. Okay, GE I can write in denominator, or I can write GE like this: re square upon GM. Simple. Okay, so GME got. So what is GH upon GE? What is GH upon GE? GH upon GE is equal to, it is re square upon re plus h whole square. Any doubt? Okay, yes, simple mathematical steps. Any doubt? Okay, now what is next step? Yes, next step that you have to remember. In this denominator, you have to take re as common. Re plus h, there is whole square. So if you take re square, outside we have to write re square. So GH upon GE is equal to, numerator as it is, re square. In denominator you have to take re common. So it is re square. Yes. From here, re common, so it is 1. See, whatever term you take common means, in bracket you have to divide by that term. If you are taking re common, then re upon re 1, and here it will be h upon re. So here it is h upon re whole square. Any doubt? Hello? Any doubt? Sure? Okay, so yes, GH upon GE is equal to re square. Here we have to take re common. Okay, so it is re square 1 plus h upon re whole square. So the re square. So therefore, GH is equal to, it is GE upon 1 plus h upon re whole square. Or you can write this equation as, therefore, GH is equal to GE. If you write this term in numerator, it is h upon r raised to minus 2. So it is equation of gravitational acceleration above surface of Earth. Okay, GE 9.8. RE radius of Earth, it is given. So if you are given any height, the object is at height 100 meter, 500 meter, 1000 meter, then yes, simply you have to put value of h. Clear about this? Okay, so yes, you have to remember this equation. Okay, there is one special case. Okay, if h is very less than I, okay, if h is very less than I, if h is very less than I, then what happens? See, if h is very less than I, okay, this 1 plus h upon I is to minus 2. It is binomial expansion. So how to solve this binomial expansion? 1 plus h upon I is to minus 2. How to solve this binomial expansion? Okay, that I will explain you in Zoom meeting. I will explain you in Zoom meeting. Okay, how to find 1 plus h upon I is to minus 2, because it is one mathematical concept. It will need some space and some time. Okay, so yes, I will explain. I will definitely explain it, okay? But how to remember this? Now, what is meaning of h is very less than RE? RE, that is radius of Earth. It is 6400 kilometer. And if I am taking h is equal to 10 meter, then observe, see, h is very small compared to RE. Yes, h is very small compared to RE. Yes or no? So, during such cases, what happens? How to expand this? Yes, here I am writing direct answer, but how to actually understand this, I will explain in Zoom meeting. So here I can write this GH is equal to, it is GE. Here I can write 1. See, simple. How to remember? If h is very less than I, means this second term is very small. If second term is very small, this power you have to multiply to second term, means 1 as it is, first term as it is, okay, plus h upon RE as it is, you have to multiply this power to second term. Clear? So what happens is, therefore GH is equal to, it is GE 1 minus 2h upon RE. 1 minus 2h upon, clear? So GH is equal to, it is GE 1 minus 2h upon RE. You have to remember this equation. Clear about it? Okay, what is this equation? GH is equal to GE 1 minus 2h upon RE. Okay, it is gravitational acceleration at height h. When h is very small, then radius of Earth. Clear? Is it point? Yes or no? Yes. Now we will see 1 or 2 more points about this. See, here it is. Okay, see, GH is equal to GE 1 minus 2h upon RE. Then I can write this equation as GH is equal to GE. If I multiply this GE inside bracket, GE minus 2h upon RE, G. So GH is equal to, or I can write GH, okay, minus GE. GH minus G is equal to minus 2h upon RE G. Therefore, GH minus G upon G is equal to minus 2h upon I. Yes. Why this equation? Used to solve some examples. Okay. And meaning of this, what is meaning of minus? What is meaning of minus? As height increases, I will write it words, okay? As height increases, gravitational acceleration decreases. Gravitational acceleration decreases. Clear about this? Okay, so yes, it is one simple statement. Also, one thing, at heights which is very small, okay, 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 up to some kilometers above the surface of Earth, up to some height above the surface of Earth, gravitational acceleration GH is nearly equal to 9.8 meter per second. Yes, we know that on surface GE is equal to 9.8 meter per second square, but up to some height means if you take h is equal to 10 meter, or you can take h is equal to 10 kilometers, suppose 10 kilometers, suppose. Simply you have to put values in this equation. If you put h is equal to 10 kilometer, what is radius of Earth, and if you calculate this, GH will be nearly equal to 9.8 meter per second square. So up to some height above surface of Earth, GH is nearly equal to 9.8 meter per second square. So if you are in multi-story building, if you are on first floor, 10th floor, 15th floor, value of gravitational acceleration will be nearly 9.8 meter per second square. Nearly 9.8 meter per second square. Clear about this? Okay? So yes, this point you have to remember. Also, one point. First step, remember, GH is equal to GME upon R square. Here G constant, ME constant, R. As we are moving up above the surface, we are moving above the surface. Okay? Yes, if it is center. Okay, if we are moving away from center of Earth, then obviously R increases, and if R increases, GH decreases. So yes, you have to remember one relation, that GH is proportional to 1 upon R square. As distance increases, gravitational acceleration decreases. As distance increases, gravitational acceleration decreases. Clear? Okay. Now, see, I will explain this. See, here it is. Okay, how to write the statement directly? That is, here it was GH is equal to G1 plus H upon I is to minus 1. It was a statement. Okay. Chalo. Binomial expansion. Its equation is 1 plus x raised to n. 1 plus x raised to n. Then what is its answer? Its answer is 1 plus here it is n into x and into x upon 1 factorial. Okay? Plus n minus 1 x square above divided by 2 factorial, plus n minus 1 n minus 2 x cube divided by 3 factorial. Do you understand? Okay, n, that is power. Okay, x means this term divided by 1 factorial, and n minus 1 x square 2 factorial, and n minus 1 n minus 2 x cube upon 3 factorial. Factorial means what? See, here I will write. 3 factorial means it is 3 into 2 into 1. Okay. 10 factorial means it is 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Clear? So it is minimum factorial. Okay. Now what happens? See, if this x term is very small, if x is very small, then what happens? Here it is only x, but here it is x square. If you have one value 0.001 and if you perform it square, then it is very small. If it performs cube, it is again very small. So when x is very small, terms having higher order or higher power, they tend to 0. They tend to 0. Means this term becomes nearly 0. This term becomes nearly 0. There are only two terms. That is 1 plus x raised to n. It is 1 plus nx. It is 1 plus nx. Okay. Here it is 1 plus h upon r raised to minus 2. H upon r, 10 meter or 10 kilometer, suppose 10 kilometer upon 6400. This answer will be very, very small. This answer will be very, very small. So simple. See, 1 x. You have to multiply this n to second term. Multiply to this n second term. Means minus 2 here. Clear? So yes, you have to remember this binomial expansion. Okay, it is reason. Clear? Any doubt? So yes, it is one. See, it is this term you do not have to write it clearly. Okay, it is extra. Okay, it is extra. Clear? Any doubt? Okay? So yes, this is it for today.